Hi everyone, we're going to show that Z sub 5 take away 0 forms a cyclic group under multiplication modulo 5. So basically we have to show that it's a group and also show that it's cyclic. So let's fill it out. So we want multiplication modulo 5 and we want to take away 0. So this is 1, 2, 3, 4. 1, 2, 3, 4, and we're multiplying. So it's 1, 2, 3, 4. 1, 2, 3, 4. 4. Now 2 times 3 is 6. And you divide that by 5, you get a remainder of 1. 2 times 4 is 8. Divide that by 5, you'll get a remainder of 3. And then we already did 3 and 2. And that gives us the 1. And 3 is 9. Divide that by 5. And you get a remainder of 4. And 12. Multiply these two. Divide that by 5. That's 10, but the remainder is 2. And you finish up the rest. And now we have to show that it's a group. So to show that it's group, we know that the table's closed. That means 1, 2, 3, 4 is our set, and no new elements appear. So table is closed, no new elements appear. All right, 1 is the identity because we're doing multiplication. All right, 1 appears in every row and every column. So every element has a unique inverse. All right, and for the associative property, multiplication is always associative. Therefore, this is associative. So it is a group. Now, is it cyclic? Well, we know the group order is the number of elements in our group. So we have 4 in our group. So the order of group equals 4. Now, the order of the elements must equal the order of the group, or at least one element. So let's look at 2. So we want this is your order, N, and that should equal your identity, E. In our case, our identity is 1. So we want this N to be 4. So write 2 to the 4th. So this gives you 2 times 2 times 2 times 2, which equals 16. Divide that by 5, and the remainder is 1, which is your identity. You can also try it with 3 to the 4th. We want that to equal 1. So this is going to be 81. And divide this by 5, and the remainder is going to be 1. And the same thing's going to happen with 4. 4 to the 4th, the remainder will equal 1. So since our order of the elements in this case is 4, and the order of the group is 4, that means the group is cyclic. All right, and the next question, it says, show that C6, take away 0, does not form a group. So this is C6, 1 time under multiplication. So 1 times 1 is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So our group should have the set 1, 2, 3, 4, 5. Now, when we go through here, we get 2 times 2 is 4. 2 times 3 is going to be 5, but if you divide that out, that's going to be 0. 2 times 4 is 8, and divide that by 6, the remainder is 2. And 2 times 5 is 10. Divide by 6, you get 4. So I want to find another 0, because this one was kind of hard. Let's do another 0. We have 4 times 3. So 4 times 3 is 12. Divide by 6. The remainder is 0. All right. Let's do 3 times 4. That's going to be 0. And then the last part's just going to be 5, 4, 3, 2, 1. The point being is that 0 here is not in our group. A new element appeared. That means the group is not closed. So not closed. Well, let's not say group. So the Cayley table is not closed. So it is not a group. And that's it. Thank you. Have a nice day. Bye-bye.